Hello, this is Nathan Morley with another video in the LEGO Salvage truck. So hopefully some of you at least saw one of the previous videos I made where I tried making an electromechanical mechanism to control the speed of the main motors, and that really failed very interestingly in that the thing melted. It was a disaster. So this is my attempt at making a fully electronic speed controller. Now, key to this thing working is this component here. This is a dual potentiometer, in this case 100 kiloohms. What it is 200 kiloohm potentiometers that are mechanically connected but electrically isolated. So, one of the potentiometers is being monitored by this integrated circuit. It's a 324, it's a quad op-amp comparator. So it monitors the resistance and then activates 4 outputs in sequence. Those are pins 1, 7, 8, and 14. 1 and 14 are not really of any concern to me. So pins 3 and 8 are each connected up to 3 relays each, set up in pairs. So the first pair is this one. These are connected, the outputs of them are connected up to this little switch here, in which, using the switch, you can select which relay is connected up to this big double pull, double throw mechanical relay. This is used in controlling the direction of the motor once it gets going. Direction changes take place either when pin 7 is deactivated or when pin 8 is activated. Now, the second set of relays that it controls is this pair. This pair connects the second potentiometer in different ways to the 555 timer here. Now, the way it works is as you turn the potentiometer, the speed of the motor decreases. It decreases down to 0, at which point, assuming it's going forward to begin with, then pin 7 becomes deactivated, the motor stops. You turn a little more, pin 7 becomes deactivated as well, and depending on how you have it set up, when either of those two events happen, this relay will change position. Well, it will also change how the second potentiometer is connected to the timer. So as you keep turning it in the other direction with pin 7 deactivated, the frequency of the pulses put out by the timer will increase, so the motor will speed up. It's a really cool system in that it combines speed and direction into a single control input, which is very useful for the mechanical system that I'm using it for. Now, the third pair of relays is these two here, which it's really weird. When pin 7 is activated but pin 8 is deactivated, the timer here manages to send a really bogus output signal that tries to make it to this relay here, which sends power to the main solid-state relay that actually controls the speed. So what I did is put in these 2 relays, which when pin 7 is activated and pin 8 is deactivated, send a signal to this relay that overwhelms whatever the timer is attempting to send to it. Now, this overwhelming signal will cease immediately when pin 7 is deactivated or 8 is activated. Now, yeah, that's pretty much about it. Hopefully I'll be able to make another video to show you how this thing actually turned out. So, see you later.